Welcome class to lesson 9.4a. We're going to break this into two parts. This lesson will be on a worksheet, so we're not using our student journal for now. So make sure you have a worksheet for 9.4a. For here, we're going to use some color pencils if you have it. If not, just trace it in dark. A calculator handy and this packet. We're also going to use a unit circle. So if you don't have a unit circle, go ahead and pause this video, grab your unit circle, and we're going to use it in a little bit. Okay. All right. The notes look like this. If you do need it from home, the link is on the weekly agenda for you to look at. Okay, it does say we're going to explore what the graph of sines and cosines look like. Today we're going to concentrate on sine first and look at these periodic functions. This one's an explorer, so you can work with a partner or work on your own to get some values using a calculator this time. So unit circle to help us. Ready? I'm going to start you out. I'm going to ask you to pause the video and continue it using your own unit circle to see what this graph looks like. So we're going to graph what the sine of x looks like. So on the unit circle, ready? On the unit circle, the sine value is the y value. So go to your unit circle at 0 degrees. That's straight to the right. And I want the y value, please. So the y value straight at 0 degrees is exactly 0. And to graph this, it looks weird, but in the x direction, we're going to graph the angles. And in the y direction, we're going to graph the sine value, whatever the answer to our sine value comes out to be. Okay, so in the x direction at 0 degrees, I'm going to graph 0. So we're going to place a dot exactly at 0, 0. All right, back to the unit circle. Go to 45 degrees, please. Go out straight to the point, and we're going to look for the y value at 45 degrees. And that's exactly square root of 2 over 2. Because we're sketching this, I'm going to give the decimal approximation for this. So if you use your calculator real quick to verify for me, type in square root of 2 divided by 2, and it should come out to a decimal. Okay, check with me, please. I got about 0.71, about 0.71, and we're approximating this, so we're going to sketch this out. 45 degrees is exactly, I know this is small, but that's 90 degrees right there. So 0 to 90 degrees, so perfectly in between. And this is 0.5 and 1 is up here. So it's more than that 0.5, somewhere around right there. Go ahead and make a dot for me to represent that 45 degree. All right, continuing on our circle. Back to unit circle at 90 degrees, straight up. Get that y value, and the y value is 1. So we're going to graph at 90 degrees, up one whole space. Remember, this is 0.5, 1 is up here. Okay, 135, go to the left, pointing at 135 degrees. The y value is greater than 2 over 2. Again, approximately 0.7. And then at 180 degrees, straight to the left, take the y value, and we drop back down to 0. We're going to plot the point 180 degrees and 0. As you can see, we're going to continue going through the circle, concentrating on these key points to help us graph. I want you to keep going all the way to 540 degrees. So you're going to pass the circle 360 and keep going by 45s all the way through. Go ahead and pause the video, please, and take a look at what you get. Continue the video when you're ready to check. All right. Did you get a negative value at 225? Remember, you're taking the y values and you're going to graph down at approximately negative 0.7. If you went all the way through, let me show you what the overall looks like now. You went all the way through, your sine curve should look something like this. Goes up, bump, and then down bump. And then once you hit 360, you kind of start that cycle again. So you go up bump, and I ran out of room, but next one would have been a down bump. Okay? It says, now let's answer these questions about the graph of the function y equals sine of x. And pause the video, answer these questions for me, and see how you do, and replay the video when you're ready to check your answers. It says, describe the shape of the graph. Some people call it curves. There's a lot of ups and down curves, and other people I see a lot of hills, and I see a lot of valleys, hills and valleys all the way through. Where does the pattern start to repeat itself? So if you're looking here at 0, there's an up bump, a down bump, and then the cycle repeats. So there's an up bump and a down bump. So it says, when does it repeat itself? It starts to repeat exactly at this 360 when we made a complete circle. It says, what is the maximum value? I see a max. It says, how high did it go? How high? It was the highest value of 1. So the highest value went up 1. The lowest it went was -1. So you look at all these values here, the lowest was -1. And now it's asking, what's the distance between the max and min? Well, the max was up by 1 and the min was down by 1. So, oh, I'm sorry, I misread that. Maximum values. I'm sorry. The maximum right here is at 90 degrees, and the maximum way over here was at, I can't read that right there, but it was 450 degrees. So from max to max, what's the distance between those maxes? It was 306 degrees apart. Okay. All right, some vocab for you to fill in, please. And notice I did change this word to cycle. So go ahead and make that change into the notes, please. All right, periodic function is when it's repeating. You have a function that repeats itself. That's called a periodic function. A cycle is the shortest repeating portion of the graph. So you want to know in the x direction, what is that shortest amount that makes the graph repeat? A period is the horizontal length of each of those cycles. How long was it? In physics, for those of you who take physics, a period is very similar to wavelength. So the length of the wave before it repeats itself. So common concept of wavelength in physics is period. Amplitude is how high, how low. So what we do is we take half and we take the highest and the lowest and we take half, or you could think about it from the middle, how high and how low. Please make yourself a note that amplitude is always a positive value. Amplitude is always a positive value. It's the distance from the middle, we call midline, to the peak at a max or a valley for a min. All right, here are just some ideas of what is a period, and let's highlight. So a highlighter would be nice, or trace if you will. Find out when does this start repeating. So I need the horizontal distance of when this is repeating. Go ahead and give these a try. These are called our period. So label this in your notes what the period is, and then replay the video when you're ready to check them. All right, in letter A, I see it starts down here. There's a really tall peak and goes down, and then a little peak, and then it starts over. High peak, down, and then little peak. So you can see that's repeating. For some students, it helps to kind of put a block around it. And it's like, if I block that out or I highlight that section right there and I repeat that, it's kind of like copy paste. If you're able to cut this, copy paste, then you know these are identical, then that's where it starts repeating. So from 0 to 4, the period is 4. Okay, again, pause the video, go ahead and try the others if you didn't do so already, and then replay just to check your work. Letter B, let's see how you did. I had a cone and then a little loop on the bottom, another cone and loop, and there it is. Now look at the numbers, they're slightly different. So from 0 all the way to 10, it repeats itself, and then 10 to 20. So the period would be 10. So watching the labeling is very important. Letter C, how did you do? Sorry, my box is a little off, but it's 0. It goes flat, peak, peak, and then again, flat, peak, peak. So now it's repeating that pattern. Now take a look, I'm a little off, but I'm a little off here. So really it's right in between, and look at what's labeled. It takes 2 marks to reach 1 pi. It takes 2 marks to reach 2 pi. And then 2 marks to reach 3 pi. So it's right between 2 pi and 3 pi. So it's 2 5.5 pi. 2.5 pi is 1 period, or 5 halves, which is 2.5. All right, last one. How did you do? It was 2 pi. It was across, up, down, across, and then it starts repeating flat at 0. Again, right here at exactly 2 pi. Check your work, make any corrections. All right, now it's talking about amplitude again. When you're taking a look at amplitude, remember you can look at where was the max and where was the min, and you can't take that in half. The other way is find out where that middle is. Find out where that middle horizontal line would be, and then from the middle, how high to get to a peak max, and how high to get to that min low. And it should be the same. So how high was it? And look at the scale. These are counting by 1. So up 1, up 2. The amplitude is 2. Okay. All right, let's try this. Remember, you want to find where that midline is, perfectly in the middle. Again, from there, how high, and then down to how low. And that is 1 away. Do look at some of these. The scales are kind of mislabeled, but these were counting by 1s. All right, here we go. Try it again. Draw that horizontal line. It does help your eye a little bit. From here, ooh, see, it's a little tricky. The font's kind of small, but it's not counting by 1s. Sorry. This one is going 2, 4, 6. I see a 6 there. So really, this is down 2, down 4. So every block's actually worth 2. So just careful on what's labeled, okay? And last one, ready to check? Did you draw that midline? Did you cut that perfectly horizontal in half? And then if I look at the scale, it's 1, 2, 3, 4. So they're counting by 1s. So from the middle here, 1, 2, 3. The amplitude is 3. Remember, always positive value, even if you're counting down to a minimum peak. Okay, so always positive. All right, it says use these graphs, please, to compare what these are similar or different. So here's a basic sine of x, what it looks like, and here's what a cosine looks like. So you take a look at both of them. They look pretty similar. Okay, I want to look at period again. Period is how long does it take to repeat? If I start at 0 here, I see a up bump, a down bump, and then it starts over. So from 0 all the way to 2 pi is going to be my period. Amplitude is from the middle straight up, and that was 1 unit away. Y-intercept is where does it cross y? Here's my y on the left here, and it crosses there at 0, 0. X-intercept, where does it cross the x? It crosses here at 0, and then it touches again, not pi halves, that's 90 degrees, but exactly 1 pi, which is 180 degrees. Not at that 270, but 2 pi, 360. So here are a few points. Remember, it continues forever to the left and forever to the right, but here are some x-intercepts. Notice they're 1 pi apart. So the next one I would say would be at 3 pi and 4 pi and 5 pi. Even if you go in the negative direction, it'd be negative 1 pi, negative 2 pi, negative 3 pi. Okay? All right, take a look at cosine. Period. Now, if I start up here, I go down the hill, down even further, and then all the way up. And then now I repeat. So from here, I go down again. So from the highest peak to the next highest peak, it was 2 pi. So the period is still the same. It's 2 pi. Amplitude is perfectly in the middle to that max or min, exactly 1. Now, be careful here. The y-intercept's quite different. If you take on the left side, the y-intercept doesn't cross here at 0. It actually crosses up at the amplitude, right at the highest peak there. So the amplitude here was, or the y-intercept was 0, 1. The x-intercepts are not the same either. Okay, it was not at 1 pi, it was half of that. So not at 180, but half of it, which is 90 degrees, and not at pi or 2 pi is exactly at 3 pi halves, which is 270 degrees. So you can label all that's there, but this was 90, this was 270, and way up there 540. Okay, again, these are about 1 pi apart, 180 degrees apart. So from 90 to 270, so they're exactly 1 pi apart. All right, so those are the relationships again. Just overall, how can you see things that are similar about the sine and cosine graphs? If you take a look at their shapes, they're pretty similar. If you look at their period, look at the periods here. It takes 2 pi to repeat. Here it takes 2 pi to repeat. So their period is exactly the same, and their amplitude is even the same. Their shape is very similar. It waves up and down, up and down. They just happen to start at a different spot. So if you look at their y-intercepts, the y-intercept for a sine usually starts at 0, and a cosine usually starts up at the amplitude, up high on a peak. Okay? And you can tell all their x and y-intercepts are different too. All right. Let's take a little moment to take a look at one more time what the sine function is. So this is the one we sketched way at the beginning when you use your unit circle, the amplitude of 1, a period of 2 pi, and a y-intercept of 0, 0. What you're going to do in a moment, I'm going to have you pause the video in just a moment. You're going to do a little bit of exploration. I really do want you to please try on your own before you check your answers. Please, it makes your learning a lot better. So what you're about to do is you're going to please go to desmos.com, okay? And you're going to type in, and it does say, please type in the original equation y equals sine x into desmos.com. And then what I want you to do is add a second equation. The second equation that you're going to graph right here on this graph is type in y equals 2 sine x. When you type this in, it is going to graph this for you. It's going to graph this for you so that you can see what this looks like. So graph the original y equals sine x and graph in a different line y equals 2 sine x and go and graph it on the same graph so that you can see what's different, okay? If you have color pencil or a pen, I would recommend it with different colors so you can see the difference of them. And just for part of your exploration, this is what I'd like you to try in Desmos. Type in for me after you do this problem, type in just the letter A right here. So you go to y equals, type in A, like the actual letter A, sine x. When you do that, there's this little button that's going to pop up and it says add slider. Click on that. When you click on that, you're able to slide that value, that number. You're able to change that number. I'd like you to see what happens to the graph if that A value in the front was 3 or 4 or 1/2 or 1/4. Try these and see what happens to the graph. And then try these different numbers. Jot down for me what does that number do to that graph, okay? So you're going to try this 3 times for me, one with the letter A in the front. So try graphs 1, 2, and 3, please. Then play the video after you completed those 3 graphs. You sketched them all and you kind of played around and discovered what those varying numbers do and how does it change on each graph, okay? All right. So I hope you finished those 3 now that you continue the video. Now you're going to check the answers, okay? So for graph 1, your answer for 2 sine x should look like this. The amplitude here, it goes high as 2 and low as -2. So now check your response. The amplitude was up 2. The period didn't change. The up bump and down bump still stopped and started at 2 pi, so that doesn't change. And the y-intercept started at 0, 0, 0 as well, so that did not change, okay? So the A value is the amplitude. That's the same thing as our vertical stretch and vertical shrink. Yep, it's still the same number in the front. Vertical stretch, if it's big, big, big. Vertical shrink, if it's there and it doesn't change the period at all. Now, if you try those negative ones, it didn't make them flip. It didn't make them reflect over that x-axis. Okay? graph 2. If you altered that number on the side, that plus C, it does move. Look at that. It went moving all the way up. So the amplitude is still 1. Remember, you look in the middle, and then from the middle line up is 1. The period remained the same. I started here, I up bump, down bump, and I ended back in the same spot at 2 pi. Okay, and the y-intercept here is different. I'm not starting at 0, 0. I'm starting way up at 0, 2. So that C is your vertical shift, all right? The transformation is that translation either up or down. All right, and this one was a little strange. This number is right in front of that B. If you change these numbers to something big versus something small, you'll see something very different. So let's take a look at the amplitude. The amplitude here goes from here to just 1. So it stayed the same. It did not change the amplitude at all, but the period is different. Look at this. I start at 0. Here's my up bump. Here's my down bump. And now I'm about to start over. So 1 pi. From 0 to 1 pi is my new period. Alright, and the y-intercept stayed the same. I started at 0, 0. So that number in the front of x, not in front of the trig function, not in the front of sine, but in front of the x value right here, actually changes that period. It changes of how long it takes for that cycle to repeat itself. Alright, so let's fill in some vocab for yourself. That graph will have an amplitude of the A. Remember, it's always a positive value. So if that number is big, that is actually a vertical stretch. And if that A value is small, it will be a vertical shrink. And if that number is negative, that's the reflection. So treat that totally separate from the amplitude. The number on the side is your vertical shift. All right, so it's either positive translates up, negative translates down. Now, the period is a little tricky. So this is our new part. This is where we're going to add to the notes. So usually it takes 2 pi for it to repeat itself. So for the sine, it was up bump, down bump, and then it repeats. And it takes 2 pi or 360 degrees to repeat. You're going to take that B value. You're going to take 2 pi and divide by that B, that number in front of x. Now, 2 pi is exactly 360. So if you want to think of this in terms of 360 degrees instead of radian, you may. So 360 degrees divided by that B value will be your period as well. Okay? All right, let's practice a few. So given an equation, you need to identify the parts of the graph. So we're not graphing here yet, but we are going to identify. So which of the number represents amplitude? Amplitude was that A value, that number in the front. So it's that 7. Here I don't see a number, which means it's 1. And the number way on that side, either plus or minus, is that negative 5. So you want to fill in the blanks for me, please. Now, for the period, you always do that 2 pi divided by that B, and 2 pi divided by 1 stays at 2 pi. So period doesn't change. Remember, you can do this in 360 as well. In 360 degrees divided by 1, it stays at 360. All right, let's do the next one. Amplitude is the number in the front. Oop, what number is in the front here? I don't see it. Remember, it's not 0, it is 1. Okay, here's B, 4, and I don't see a number plus something or minus something. That is nothing, 0. So fill in your vertical shift. Now take a look at that period. I have 2 pi. 2 pi cut into 4. If I reduce 2 over 4 is 1/2. So 1/2 of a pi, or pi halves. Now if you change this as a degree, 360 degree cut into 4 equal parts, and it's exactly 90 degrees. So it's going to start and finish within 90 degrees. Okay? All right, last one. Looking at this combination, the amplitude is the number in the front. Remember, amplitude is supposed to be a positive value. Okay? So A is negative 5, but the amplitude is 5. That negative just tells me it was sad. It was reflected over the x-axis. So that's something to think about when you're looking at graphs or how we're going to sketch these in the future. vertical shift is that number lonely on the side, and that was up 3. Now, look at that period. That b is going to change our period. So what is 2 pi divided by 2? Reduced down, 2 divided by 2 is 1. So exactly 1 pi. Or in the degree world, 360 divided by 2. So within 180 degrees, I'm going to have an up bump and a down bump before it starts repeating after the 180 degrees. All right. And remember this and refer back to this when you need to do this on your homework as well. All right, we're going to do just quick identifying. Again, I'm going to go real quick, so you're welcome to pause the video anytime you need to, and then replay the video when you're ready to check. Okay, so please, it says describe the transformation first, then match the equation to the picture. So for example, taking a look at this first one, before you match these are key things to look at. What's the amplitude? Are there any vertical translations? And what's the period? Okay, so in this problem, the amplitude in the front is 3. There's a 1 here, so 2 pi divided by 1 is still 2 pi. And I saw no number on the side, so there weren't any, or you could write 0. Okay, pause the video, please. Go through each one of these and identify all the different things that you can use to describe any transformations. Okay, replay the video when you're ready to check. All right. Welcome. I hope that you tried it all. Before you continue watching this, please pause and try it and go ahead and check all your answers. And that was fast, so go ahead and pause the video and check them all. Notice this is the only one here that had a little negative sign. So did you mention anything about reflection over the x-axis? Okay. All right, now we're going to play a matching game. We want to see which of these matches what we described over here. So for me, when I'm looking at these, the easiest way is to find that midline, that middle line. So I'm going to see that this right here was at 0. So there was no vertical shift at all. But then I noticed there's other ones that are at 0. So these 3 graphs were exactly at 0. So if I look at my equations, there were 3 of these problems where there were no vertical shifts, okay, or 0. I'm going to take a look at this first one. From there, the period did not change, but look at that amplitude. The amplitude is up 3. So if I look at mine, I have 2 options. I have this one here that's up 3, down 3. So that has an amplitude of 3, but this one is also up 3, down 3. And this one's up 3, down 3, but oh, wait, this is down bump and then up bump. So it's not this first one. All right, but this one's 2 pi. Notice here it goes up bump and down bump. And here it's up, down, up, down. So this one's a double. So this period was changed. This period was changed. So this is the only one that didn't change at 2 pi. That is for graph A. All right, let's take a look at this one here. Where's none? This one had a reflection. This one it is. This is the one that got flipped over. And this was down bump, then up bump. So it was flipped around. So option E for number 5. And so this last one here, this is the one where the period was skinnier. So it's up bump, down bump faster. Within 1 pi, it repeated. And then another pi, it repeated. Okay, so that one would be option G. All right, let's take a look at a couple other ones. How about a vertical shift of -1? All right, so this is in the middle at -1. Number 4 is at -1, and number 6 is also down 1. So let's take a look at these 3 and see which one matches. I can see right here that has an amplitude of 1. If I look at my choices, this one's up 1, down 1. This one's up 1, down 1. Oh, this one's 3, so not that one. Ooh, it also knows a pi, so it's going to repeat faster. All right, so from here, oh, that's 2 pi for it to repeat. So I'm going to go to this one. Here it is, up bump, down bump, and that's 1 pi. And then up bump, down bump, and that's 2 pi. So it takes 1 pi, so that right there is going to be option B. So exactly 1 pi is going to repeat. All right. This one has an amplitude of 3. So there's that one, the amplitude of 3. And the one down here has an amplitude of 1. No change on the period, which is this one. All right, so we got the negative ones. Now let's see what else we have. I have this one that goes down 3. So look at my equations. This one has a vertical shift down 3. So that's the only one. That's our match. And lastly, the one way up here, number 1, has that middle line up 3 spaces. So that's my vertical shift up 3. And that is letter F. Alright, so we've done all the matching. Alright, I'm sorry, there's a few more examples just to help you out on your homework. So would you please add these extra examples to your notes for me, please? Anywhere you have space, go ahead and pause the video and copy these instructions down. And I'm going to guide you through how to write the equation from these given information, okay? Alright, play the video when you're ready to check your work. All right, taking a look at option A, they give you the amplitude of 4. It says the vertical shift is 2. Now, that phase shift tells us what our B value is, but it's not exactly 5. Remember, you have to solve. So I'm going to set it equal to 360 divided by B. My answer is 5. I just don't know what B is. So we're going to set it equal to cross multiply. Stick a 1 under that 5 for me. We're going to crisscross and multiply. So 5 times B on one side, and then 1 times 360 on the other side, and I get 5B equals 360. Okay? And then finish solving here. Let's divide. Hit divide on both sides, and this will tell me what B has to equal to put it back into my equation. All right, we're almost done. So into the equation it goes, the amplitude in the front, the B value, that gives me my period of 5, and then my vertical shift goes on the side. All right, so put it all together, and this is what I see. And how did I know to use cosine? Because they told me to. So if this was sine instead, I would write my equation with sine instead. Okay? All right, pause the video. I really want you to try this on your own first, and then replay the video and try and check to see how do you do. All right, were you able to try it first before you play this? Let's check it. Start with labeling. Did you recognize that the A has to be negative because of the reflection? And now the solving. Now it's weird. Over here I use 360, and over here I'm purposely actually using 2 pi. Those pi's will cancel out nice later, so I'm going to purposely use 2 pi since this is already a radian. Okay? And originally with A, this wasn't a radian, so I used 360. All right, ready? I'm going to cross multiply still, stick a 1 under here. So pi times B on one side, 1 times 2 pi on the other side. And I want to solve for B. Remember, pi is a number. So I'm going to go ahead and divide both sides by pi. And say bye-bye to those pi's. B is exactly 2. All right, fill in your equation. How did you do? Do you remember that negative sign? There was a reflect over the x. Did you remember to put that there? All right, now that's the end. Thank you for paying attention to your notes for lesson 9-4. Go ahead and try your assignment. It is a paper copy worksheet. Print it if you're at home and get it in class if you are there. You have a great day.